Section 2.5, it's called complex numbers and roots. So complex numbers and complex roots. Let's start with a bit of a warm-up. We've got 2x squared plus 12x minus 18. We're asked to solve it by completing the square. So kind of thinking about the steps. I'm not going to write down the numbers that I've done in the past for the notes, but I want to write like the numbers of the steps, that is. I'm going to write down numbers, but I'm not going to write down like this is step 1, this is step 2, but kind of following some of those steps anyways. The first step is like get all the variable terms on one side, get all the constants on the other. Well, thankfully we already have that. The next step is, if you need to, divide by the a value. So if the a value is not 1, we need to divide by that a value. So let's divide everything by 2, which gives us x squared plus 12x, plus 6x, my apologies, equals -9. Now, the most important step of the completing the square process is, well, the completing the square step. So what we're going to do is we're going to take our b value, divide it by 2, and square it. In this case, our b value is now 6. We're going to divide that by 2 and square it. 6 divided by 2 is 3, and 3 squared gives us 9. So we're going to add 9 to both sides of the equation, which I'm going to run out of space vertically there, so I'm going to move that over here. That's going to give us x squared, plus 6x plus 9, and on the right side we have -9 plus 9, which gives us 0. To keep solving for x, next up we're supposed to factor, so we're going to have that factored outside, x squared plus 6x plus 9. That's a perfect squared trinomial, so it is factorable into x plus 3 squared, still equal to 0. Step 5, if you're following along those steps, was take the square root of both sides. The square root of something squared, well, the square and the square root just cancel out, so we're just left with x plus 3. Let me zoom a little bit out so that you can see everything. And then on the right side, the square root of 0 is just 0. We don't need to worry about plus or minus 0 because there's no such thing as positive 0 or negative 0. It's just 0. And to finalize it, solving for x, we're going to subtract 3 from both sides, and we're going to end up with x equals -3. So we followed all 6 of the steps that we had in our notes. We just don't need to label every single step. Now the second part, it says find the zeros of the graph, or find the zeros of each function using a graph. Now using a graph, you're going to use a graphing calculator for it. So let me use a calculator. I'll show you. I just don't feel like switching screens for this right now. So you're going to your graph, you're going to y equals, and you're going to type in the function x squared plus 5x minus 8. And you'll look at the graph and you'll see you've got 2 different zeros. So finding the zeros, if you do second trace option number 2 for the zeros, I'm going to do the one on the left side first. So I'm going to move my cursor, and it's kind of hard for me to see it this way, but I'm going to move it so it's a little bit to the left of it and hit enter. And then I'm going to move it so it's a little bit to the right of it, hit enter, and put my guess somewhere close to it. And it gives me an x value of x equals -6.27. Now I'm going to find the other one as well. I'm going to do the same process. So second trace 0, and now this time I got to move over to the one on the right. Waiting for it to get there. There we go. So a little to the left, put a little to the right, put your guess kind of close to it, and the other one's at about 1.27. So the other option is 1.27. The second graph, we've got, let me graph that. We got x squared plus 2x plus 6. So again, typing that in, there we go, x squared plus 2x plus 6. And then when we graph it, we're looking for the zeros, but this graph is not going to touch the x-axis. It has no real zeros. I'm going to emphasize the real part because we're going to investigate what that really means. So it doesn't cross the x-axis. So what we're going to say, it has no real, and I'm going to emphasize that, zeros. We'll talk what I mean about that in just a little bit. For our warm-up, the first thing we're going to do is, for our goals for the day, the first thing we're going to do is define and use imaginary and complex numbers. Imaginary? Yes, that's real. That was a confusing sentence. So we're also going to solve quadratic equations with complex roots. So the first thing we need to talk about is, yes, we can finally take the square root of a negative number. Let me give you the definition. The square root of -1 is the definition of an imaginary number. And since it's not like a real number, you can't find any number times itself that gives you -1, we're going to define it as the letter I. So anytime we see the letter I, we're going to talk about it as the imaginary number. So let's see if we can figure out how to use this. So for example, we're asked to, and it says solve, really this should say simplify. Solve means it's set equal to something. Simplify just means, well, take what you have and make it simpler. So we're asked to simplify, not solve. My apologies. So the square root of negative 16, what I would encourage you to do is break it up. It's kind of like we did in the past with like the square root of 24. 24 is not a square number, so we had to break it up. I would take the square root of negative 16 and also break it up into the square root of 16 times the square root of negative 1. Because I know how to do both those parts separately. The square root of 16 is 4. The square root of negative 1, now we know, is defined as I. So that answer just comes out to be 4I. Now the next one, the square root of negative 27. 27 is not a nice square number, but that's okay. We can still break it up. So we can make it square root of 27 times the square root of negative 1. Now 27, to get it in simplest radical form, we're going to have to find some factors of it. Remember, when you're doing factors of a square term or a square root, we want to find one that's a nice square number. So I'm going to take square root of 9 times the square root of 3, and then that square root of negative 1, we'll clean that up in just a second. So the reason we break it up like this is so that way we have a smaller number underneath our square root. It's a little bit more manageable. Now we know the square root of 9 is 3. The square root of 3 is the square root of 3. That's not any simpler than it was. But the square root of negative 1 is I. So that is one way we can write our answer. 3 root 3 times I. Now typically you'll see it written a little bit differently, just so you don't accidentally put the I underneath the square root. So sometimes you'll see it written as 3I times the square root of 3. Now we're going to do something pretty similar for this last one here. Square root of negative 50. We have the square root of 50 times the square root of negative 1. Well, 50 we can break up, and so we can make it the square root of 25 times the square root of 2, because 25 times 2 gives us 50, times the square root of negative 1. Square root of 25 is 5, the square root of 2 is still square root of 2, and then square root of negative 1 is I. So rewriting it, 5I square root of 2. So we can now finally take square roots of negative numbers. Now let's try this when we're actually doing a solving problem. On the next page, we're asked to solve 5x squared plus 90 equals 0. To solve for this, the first thing we're going to do is we're just going to use some inverse operations. So we're going to subtract 90 from both sides. We got 5x squared equals negative 90. We're going to keep solving for x. We're kind of working through PEMDAS or GEMDAS backwards, so we're working through like SADMEP or SADMEG, depending on whether you're looking at it, which way you're looking at it. We're going to divide both sides by 5. We're going to deal with that exponent at the last. So x squared, I missed the 0, I'm sorry, negative 90. So x squared, after we divide that side by 5, negative 90 divided by 5 is negative 18. Now, just like we did in the past, we're going to take the square root of both sides, and we end up with x, because the square root of something squared is just that term, so square root of x squared is just x. Now, negative 18, we're going to break into 18 and negative 1. Now, 18, I made a mistake. Hopefully you caught the mistake that I made. I forgot to include something. This is something that whenever we insert a square root in order to solve, we're going to get a positive output and a negative output. Because we could plug in a positive term and square it and get negative 18. Worry about that in a second. We could also plug in a negative. So it's going to be plus or minus, positive or negative. And then 18, let's break that up into square root of 9 times the square root of 2. And then the square root of negative 1, that's I. Cleaning this up a little bit more, we got plus or minus, the square root of 9 is 3, and then we have the square root of 2 times I. I'm just going to do I square root of 2. So now we have the ability to solve with imaginaries.